So here's another question that we can solve using kinematics. So if I have a car that can go from 0 to 30 meters per second in 6 seconds, how fast would I be going if I could keep accelerating at that same rate for a full minute? Normally in a car, you accelerate at first and then your car kind of slows down and gets to a constant speed. It's because of all the wind resistance and things like that. But if you could keep accelerating as you did at the beginning, how fast would you be going? How far would you go in 6 seconds? And how far would you go in 1 minute? So I've got, better make a chart. Let's see. Known. What do I know? 0. What's that 0? My car can go from 0 to 30 meters per second, so it's a speed. So this is our initial speed, okay? I'm going to call it V0 instead of VI because I'm going to call the initial time times 0. So V0 is 0. We have a V final also, that's what this 30 is, 30 meters per second. And then, we have our time. T is 6 seconds. This can also be delta T in some of the equations. I'm going to call it T because delta T is the change in time. And if my initial time is 0, then final time minus 0 time is always just the time. So I'm going to call it T. It could also be delta T, is 6 seconds. So, all right, then what are we looking for? So unknown, what I'm trying to find, how fast would I be at 1 minute? So V at T equals 1 minute. And then also, how far would I go? So that would be like my delta X, or possibly my D, at T equals 6 seconds, and delta X at T equals 1 minute. Well, to keep all of my units consistent, these places where it says 1 minute, I'm going to change those to 60 seconds. So I don't forget to do that later. So I'm going to put that into my unknowns. Now all of these are SI units. All right. What to do? Draw a picture. Here's my car. I'm going this way. I start out V equals 0. Then at T equals 6 seconds, V is 30 meters per second. And then at T equals 60 seconds, I don't know what my V is. I'm looking for this X, and I'm looking for this X. So I'll call this X at T equals 6 seconds, X at T equals 30 seconds. All right. So now I've got a picture. I've got knowns, unknowns, how to figure things out. This time, I don't think that there's a single equation that you can use to get through to any of our unknowns right away. It's not obvious to me that it is. There may be a way to do it. I try to always find the shortest path to get there, but this time it's not obvious to me that there is a short path because all of my equations that I want to use include acceleration. So if I could find acceleration, then this would be easy. So I'm going to try and make an intermediate step between finding these from those by going through acceleration. So I know, let's see, acceleration is delta V over delta T. I have an initial and final V, and I have a T. So I can figure that out easily. So delta V, that's the change in V. So that would be the final, 30 meters per second minus 0 meters per second over the delta T. Remember I said I'm going to call that T, but it could also be delta T sometimes because this is T final minus T initial, and T initial is 0. So that's 6 seconds. So this is 30 divided by 6, so that is 5 meters per second squared. All right, so I've got acceleration, 5 meters per second squared. That's not what I really needed. What I needed were these things. Well, I can actually use this same equation. A is delta V over delta T. But if I use, and I know that's 5 meters per second squared, if I rearrange it, I can solve it for delta V. So delta V for 60 seconds would be this A times delta T. So that's 5 meters per second squared times 60 seconds. So the delta V would be 300. 300 meters per second, because one of those seconds cancels that. So delta V for 30 seconds, we've got, sorry, for 60 seconds. Delta V for 60 seconds, we got that. 300 meters per second. That's about 600 miles an hour, so that's pretty fast. All right. So we've got that one. Now, delta X. Delta X at those 2 different times. What I want to use is actually this equation. X final is X initial plus V naught X T plus 1/2 AX T squared. And the reason I want to do that is because if I subtract this X naught from both sides, then I get X final minus X naught. That's just delta X. That's what I'm looking for. So delta X is V naught X T plus 1/2 AX T squared. What's our initial velocity? 0. So it's come down to delta X equals 1/2 AX T squared. So delta X equals 1/2 times the same acceleration, came in useful again, 5 meters per second squared, 1/2 A, and then times T squared. Now all I have to do is take T equals 6 seconds, plug that in here, then take T equals 60 seconds, plug that into there, and I get both of those.